at completing the square, but when x squared does not equal 0. So in the previous examples, we always had the coefficient in front of x squared be 1. That basically meant in front of the bracket it'd just be 1, so there's no further steps to be done. But this time, what if the coefficient in front of x is not? Sorry, it shouldn't be 0, it should say 1 actually, my apologies. When it's not 1. So that could be 2x squared, 3x squared. What would you do in that case? Might seem easy, but it might be a bit confusing. So let's take a look at an example. For example, we might have 2x squared plus 8x plus 7. And remember, the reason we use complete the square method is to write things in the form of a x plus b squared plus c. And usually, it's not going to be a plus, it's going to be a minus. 2x squared plus 8x plus 7. Now we have a 2 in the coefficient instead of a 1. So what would happen? Well, first we're going to convert this into the brackets form that we would always do for any other example. So it's going to be 2 multiplied by x squared plus 4x. Because this 2 multiplies by x squared to give us 2x squared. And this 2 multiplies by the 4x to become 8x. And then plus 7 at the end. So if you notice just over here, up to here is just the x squared equals 1. This 2 section is the only problem. So what you can do instead is, we're just going to ignore this section for now. And we're going to use the normal complete the square method, which in this case up to here is x equals 1. So we can just do this part, and then we can add the 2 in later on. That's the step I prefer to use. So what we can do is we can rewrite this as x squared plus 4x plus 7. And then that's just the exact same workings as before. X, we divide this by 2. If you don't know this original complete the square method, watch the previous video that I made on complete the square. X plus 2, because this divides by 2 to give us 2. And the squared goes from here up to here. And of course we have our plus 2, right? We're going to square plus 2. 2 squared is 4. And remember, it's always a minus, so minus 4. And this 7, well, this 7 is going to have to carry on downwards. So it's going to become plus 7. Right? So up to here, we're pretty much alright. This is the almost complete form, except you might be tempted to simplify this to become plus 3 and x plus 2 squared, because you have a minus 4 plus 7. But the thing that you might end up forgetting is that we have this 2 from before that we need to add on. And this 2, where does it apply to? This 2 applies to all of this, not the 7, because that's not part of the original expansion, but it also applies to this minus 4, because it's the expansion from here. So this 2 applies to all this. So now if we finally simplify our answer, it's going to give us our final answer of 2 multiplied by x plus 2 squared minus 4 times 2, which is 8, right? Minus 8 plus 7. We can simplify that out to become 2. We can't really simplify this part. Let me write that in a bit better. Wait. Still not the best. 2 brackets x plus 2 squared. And then minus 8 plus 7. Now we can simplify this because we've multiplied the minus 4 by 2 already. So minus 8 plus 7 will just give us minus 1. And that is how you simplify when the coefficient is not 1. Let's take a look at one more example. We might have 3 minus 12x minus x squared. Actually, this is an example of an x being not 1, sorry, because here you can clearly see it's just 1x. But it is a good example of a different style of question. And we're supposed to rewrite this in the form a x plus b squared plus c. And that's how you know you need to use the complete the square method. You might notice the layout of this equation is slightly weird. So the first thing that you need to do if you get something like this is rearrange it into the correct form. Minus x squared minus 12x plus 3. And then it just becomes simple from there. Well, you notice the coefficient is minus, right? So you can actually add a coefficient of minus 1 like this. It's going to become minus 1 and then x squared. And then we already have the minus, so it's just going to be 12 x and our plus 3 at the end. So notice actually, this is a part of the question. This is actually another example of when the coefficient is not 1 because it's minus 1. So there's additional steps involved again. We can ignore the minus 1 for now, and we can just simplify. We can just put it into this form we can just simplify this one first. What's that going to be? Well, remember, it's going to be x, and then this divides by 2, right? So 12 divided by 2 is 6. Square moves over here, and plus 3 carries on. But there's one more. We need to square the 6, so 6 squared equals 36. Remember, it's always a minus 36 plus 3. If you don't know the reasoning behind this, watch my previous video on complete the square form. Now we have this almost done. You might be tempted to simplify this to become minus 33, but don't be tempted, because remember, we need to add it with minus 1. So we're going to have minus 1 all multiplying into all the way up to here. So if we simplify that out, that's going to become minus 1 multiplied by x plus 6 squared. Minus 1 times minus 36. A negative and a negative is going to make a positive, so plus 36 plus 3. Now we can finally simplify our answer. Minus 1, the start stays the same, but 36 plus 3 will give us 39, and that will be our final answer. Let's take a look at one last example when the coefficient is a fraction. So 1 over 10. Don't be scared by this, it's not that scary. 1 over 10x squared plus 4x minus 3 in the form a x plus b squared plus c. And as soon as you see this, you know we're supposed to use the complete the square method. 1 over 10, and that's going to be multiplying with our x squared plus our 4x actually. Now this is the part that gets a bit confusing. This 1 over 10, right? It only applies to this x squared. It doesn't apply to this 4x. If you notice our previous examples when we had minus x squared, we could put a minus 1 in front because the minus 1 applied to not only the x squared but also the minus 12x. It also had a minus in front. That's why we could add the minus in front. But here, notice, 1 over 10 only applies to this. This has just a normal 4x as 4 as the coefficient. So what we can do is, we want to keep the 1 over 10. We can multiply this 4x by 10 to give us 40x. Because 1 over 10 times by 4. So 1 over 10 times by 4 is going to, 40 is going to give us 40 over 10, right? You can write the fraction like this. It's going to become 40 over 10, which is going to be 4, right? And that's why we will multiply this coefficient of 4x by 10 to give us 40x, because 1 over 10 isn't part of this. But once you multiply it, it will return us to our original equation, and our minus 3, of course. Then we can do what we always do. We can ignore this 1 over 10 for now, and we can first simplify this expression first. That's just going to become x. Remember, the square disappears. 40 divided by 2 is 20. No x. Squared moves over here, and 20 squared, that's going to be 400, right? Remember, always a minus 400, and then the minus 3 carries on. Remember, don't be tempted to do 403 to simplify like that, because remember, this is still part of the 1 over 10. So once we get our 1 over 10 back, this applies to this entire section, giving us 1 over 10 x plus 20 squared minus 400 times 1 over 10. That's going to return us to our original, minus 400 times by 1 over 10. That's just going to give us 40, right? 40, and then our minus 3 just carries on down. Let me just change the size of this bracket. I feel like it's just a little too big, right? And then we can simplify this final section to give us a final answer of 1 over 10 x plus 20 squared minus 43. I hope this video makes sense, and in the next video we'll take a look at completing the square in order to find the center and the radius of circles, so equations of circles. Thanks for watching this video.